My name is Nick Venezia. I'll be presenting our midterm briefing for our workshop group. Our faculty advisor is Dr. Howard Absent, and our legislation is House Bill 610, the San Francisco Bay Restoration Act. I'd like to extend a quick thank you to my task team this week, Noah and Hunter. Thank you guys so much for working with us, helping prepare for this, as well as a thank you to the vesting rights, my workshop team. Thank you guys so much for being the greatest workshop team, and also I look forward to the research we have to do. So just a quick rundown of how I'll go through this presentation. I'm going to start with our legislative summary. Of course, talking about brief facts about the importance of the San Francisco Bay, and then I'll go into defining the environmental problem, as well as talking about the science of the environmental problem, as well as who the problems affect most. And then lastly, I'll talk about what's next to our research before answering any questions. So a quick legislative history. The Federal Pollution Control Act of 1948 was the first big federal government legislation to try and address pollution in water nationally. It wasn't really that effective. It wasn't until 1972 with the Clean Water Act amendment. There was actual structure to regulate pollutants within water. And then another significant part was added in 1987, the Clean Water State Revolving Fund. It was a loan service offered by the EPA to states to help them manage and clean up their waters. And all of these come together for the San Francisco Bay Restoration Act, which is an amendment that seeks to add a specific part of the Federal Water Pollution Control Act of 1948 that will address the problems within San Francisco Bay and the estuary. So the Bay Area is home to over 8 million people. Excuse me, not 8 million. Excuse me. Just go back. Some key provisions I want to go over of the San Francisco Bay Restoration Act include the establishment of a federal grant program to fund research projects and cleanup efforts within the Bay. It will also create a San Francisco Bay program within the EPA's Northwest Regional Pacific Office headquarters. In conjunction with the state of California and local governments, the office will work to manage, research, and conduct plans that will help clean up the Bay estuary with a focus on water quality improvement, endangered species recovery, and mitigation of climate change. All right, so back to the Bay Area. The Bay Area is home to over 8 million residents. It's a hub of diverse sectors such as shipping, tech, finance, and it's also the 12th largest metropolitan area in the US, with the 3rd largest urban economy. The map you're looking at here shows the 9 counties within the Bay Area. Within it, there's 100 cities and towns. And although rapid development has helped the area succeed, it's also led to the degradation of the environmental quality of the Bay. So just some quick ecological background. An estuary is a tidal mouth of a large river. It's usually where a river meets sea. So because of this, the water in estuaries is brackish, which means the salinity is in between salt water and fresh water. Because of this, estuaries have a perfect environment for a diverse range of species that have adapted to live in brackish waters. San Francisco Bay particularly is home to species that can only be found there. The San Francisco Bay is a big body of water that encompasses other bodies of water. It actually has 4 bays within it: the Sassoon Bay, the North Bay, the Central Bay, and the South Bay, all of which have different environmental qualities. There are many rivers, salt ponds, wetlands, and waterways within the San Francisco Bay. And overall, it's a sediment-rich environment, home to endemic and endangered species. So the environmental problems, there are a bunch of environmental problems that the legislation seeks to address that affect the health of the Bay. But before we focused on where there's habitat degradation, invasive species, pollution and runoff, and climate change. So the first one, environmental habitat degradation, environmental loss. Environmental alteration of the San Francisco Bay Area began with European colonialism in the 1700s. And after the 1800s, 95% of tidal marsh and wetlands were lost. As you can see on the map, the green is tidal marsh and wetlands, and as of 1998, most of it's lost. So when you lose this, you're not only losing a habitat to over 500 species, but you're also losing a climate regulator, as the tidal marsh and wetlands helped filter the contaminants that went to the bay, as well as helped regulate coastal temperatures. So the people and species most affected by this are the habitats, the native species that call the wetlands their habitat, and also due to the environmental degradation and the habitat change, fisheries in the bay have been reduced 5 to 10%. Another big problem is the diversion of fresh water from the estuary to supply the rest of California. This ends up with fragmentation of streams and rivers within the estuary, as well as it changes the salinity of the estuary as the fresh water is taken out, it becomes more salt. The next big problem we focused on was invasive species. One new invasive species was added to the bay every 14 weeks from 1961 to 1995. And currently 97% of the species within the bay are non-native. The thing about these invasive species is they have no natural predators, they disrupt food chains, and they often reproduce too much, taking resources from the native species. A big driver of this was ballast ship water. Ballast ship water is water that ships take in at their point of origin. And then once they get to their destination, they release this water. Inside can have microbes, invasive plant species, and invasive animal species. The next big environmental problem we focused on is pollution. There's a bunch of different pollution that affects the Bay Area. First of which we focused on the sewage pollution. A lot of the sewage treatment plants in the Bay Area were built in the 1950s and haven't been upgraded since. So they're very susceptible to overflow events when sea level rises, as well as when it rains a lot. These overflow events result in sewage overflow, so raw sewage can get into the bay, containing pathogens, bacteria, viruses that can affect humans and the organisms they come in contact with. This mainly affects low-lying communities in the Bay Area, which include low-income individuals and non-native U.S. citizens. There's also a problem with industrial discharge. There's 1,300 industrial facilities in the Bay Area, some of which their chemicals end up into the bay. These chemicals include mercury, copper, and lead, all of which can have adverse effects on the organisms that live in the water. For example, salmon, when they come into contact with copper, they lose their sense of smell. And without that, they find a hard time trying to spawn, as well as avoiding predators. Birds that also come into contact with lead can be very fatal. And the last pollutant when it comes to industrial pollutants is legacy pollutants, which pollutants from the past, whether they've been dumped into the bay a long time ago, or they're from facilities that are buried near the bay that seep into the bottom. Usually these legacy pollutants stay within the sediments on the bottom of the bay, but the constant influx of water in and out of the estuary causes these sediments to move, unearthing the chemicals on the bottom. Such industrial legacy pollutants like DDT, a synthetic agriculture chemical that was banned in 1972, they cause that one specifically causes paralysis and death in some organisms. There's also a problem with bottom feeders that unearth legacy pollutants, such as shrimp and small fish that eat on the bottom of the bay. And as these pollutants get into their bodies, it travels up the food chain as they're eaten by bigger organisms. So the last pollution we looked at was plastic pollution. Plastic pollution gets within the bay from sewage runoff, as well as rainwater runoff, and just plain old litter that ends up in the bay. So microplastics are broken down pieces of plastics. They're really hard to get out of the environment. And they're considered microplastics when they're broken down to less than 5 millimeters in width. They often contain PCBs, which can cause liver failure, cancer, and death within organisms. In a case study we looked at to understand how the microplastic got into the food chain and then travels up to bigger organisms was a study of 2 prey fish within the bay, top smelt and northern anchovy. They looked at 8 different locations all around the bay, 2 of which were outside urban areas to broaden the range of the research. And they found that 35% of the fish had plastics within their system, and on average, they had 0.6 to 4.5 plastic fibers in the bodies. So that's a picture of northern anchovy. You can see they'll eat microplastic, and that's a picture of northern anchovy being eaten by a tern, which is a migratory bird that stops in San Francisco Bay at certain times of the year. So as they eat these fish, the plastic bioaccumulates more and more and has significantly worse adverse effects as it moves up the food chain. So the last problem we looked at was climate change, which has already significantly started affecting the bay. Sea level rise makes that sewage treatment plant problem that I said a lot worse, because a lot of the treatment plants are located on the coast of the bay. Sea level rise also leads to salt water seeping into the freshwater sources within the estuary. Climate change leads to more powerful storms, which leads to a greater level of coastal erosion. This picture was taken from 2010 within the bay, and as you can see, within a month, a big chunk of the road is gone, coastal erosion. That divider that they circled in first, by January 20th, the end of the month, that divider ends up at the end of the coast because of storms. So climate change will make storms that cause this more frequent and also a lot stronger. And climate change will also lead to increased temperature, which leads to more moisture deficits within the bay and also a lower snowpack. The snowpack melting is where the estuary gets its fresh water. So without that, there's less fresh water for the estuary environment, and less fresh water for the human activities such as agriculture and recreational activities that depend on it. So it directly affects the economy. And so with that, I'm at the end of our presentation. 2 weeks from now, John Luca will be giving a briefing on the proposed solutions to the environmental problems I outlined. With that, I can take questions.
Over there, can we get to a microphone?
I think that they're all off, but Nick can repeat the question and
Okay,
then.
they'll repeat the question. Go ahead.
As far as the 7 or 97% non-native species, is it still going to try to reduce those species or just prevent more non-native species from coming into?
So that's a great question. That's definitely something we'll address. Oh yeah, sorry. So the question was, will the bill try to address the non-native species? Actually, can you repeat it one more time?
Will the bill try to address the current 97% of non-native species that are in the bay, or is it more about preventing more non-native?
So is the bill more about preventing more non-native species from coming in, or reducing what's currently there? Yeah, that's a good question. That's definitely more of something we'll explore later in the research when we look into the proposed solutions to the problem. So I'll definitely circle back to you if you want to learn more about that.
Other question? Go ahead.
I have a quick, maybe I just don't understand, how does sea level rise make the CSO runoff work?
Because a lot of the, like I said, the sewage treatment plants, they're on the coast. Oh, man, I'm so sorry, guys. So the question was, how does sea level rise make the sewage runoff worse, correct? Yeah, so because a lot of them are built on the coast, as sea level rise gets higher and higher, it's a lot easier for those to overflow and flood as the coast is closer.
Okay, time for one more. Here's another question. Seeing no other questions, thank you. Great.